In this video, we're going to look at the elements of a complex quotient structure, R mod I, modded out by S mod I. And the setting for this particular kind of a quotient structure is the correspondence theorem. And so I want to start by looking at the correspondence theorem. And the correspondence theorem had this setting. We had R as a ring, and it had a subring S, and it had an ideal I. And the ideal I was part of S. And we looked at the natural map between these rings and the ring R mod I. And we found out that what we had was a one-to-one correspondence. It's worth remembering that I mod I is just the set containing the coset I, or the coset 0 plus I, and this is a ring with one element. And this is our standard coset, our standard quotient ring. The elements here look like R plus capital I, where R is any I inside ring R. And the correspondence theorem said that this was a subgroup if and only if this was a subgroup. And we found out that this particular collection of objects was the set S plus I, where S was inside the subring S. But the correspondence theorem went one step further. It also said that if this was an ideal in R that contained I, then this set was an ideal. Let me write that clearer. That this set is an ideal inside R mod I. And so we had this correspondence between the ideals of R that contain I and the ideals of the ring R mod I. Now this raises the interesting question. If S mod I is an ideal of the ring R mod I, then the quotient structure R mod I, modded out by S mod I, is a quotient ring. And that raises the question, what are the elements of this complicated looking quotient ring? So what are the elements of R mod I modded by S mod I? And that's what we're going to look at in the rest of this particular video. To start with, I want to look at the basic general definition and facts. So the basic definition that we had is that R mod I consisted of everything that looked like little r plus capital I, where little r was inside the ring capital R. And we also had another thing that was important. R1 plus I was equal to R2 plus I if and only if R1 minus R2 belonged to the ideal I that we were modding out by. We need to apply this definition and this fact to our new quotient ring. So in R mod I modded by S mod I, we're going to have this. The ring is R mod I. The ideal that we are modding out by is S mod I. So a typical element inside R mod I, modded out by S mod I, is going to look like this. Well, we have to have a typical element of R mod I. That would be R plus I. And then we're going to add the ideal that we're modding out by. So our elements are going to look like R plus I plus S mod I, where R is pulled from the ring R. And the reason why this works is that this stuff here is an element in the ring R mod I, and this is the ideal we mod out by. Now, the next thing that I want to look at is that fact about when are two cosets equal. So let's look at that. So in R mod I, modded out by S mod I, when is R1 plus I plus S mod I equal to R2 plus I plus S mod I. Now, I know something, and I want to make it clear. These are two cosets, and this element here is the coset representative of R1 plus I plus the ideal S mod I, and this is the coset representative of R2 plus I plus our ideal S mod I. And two cosets are equal if and only if the difference of their two coset representatives lies inside the ideal that we are modding out by. Now, it's important to remember S mod I is the collection of things that look like little s plus I, where little s is any particular element of our ideal S. And this particular minus happens to be in the ring R mod I. So I know how to do that. This difference is just R1 minus R2 plus I, and that's the element that needs to be in S mod I. Well, when is that going to occur? That's going to occur whenever R1 minus R2 is inside S. And remember, S is an ideal of R that contains the ideal I as a subset. So we can go one step further and we can say that these two cosets up here are the same inside R mod I modded by S mod I, if and only if R1 plus S is the same as R2 plus S in the ring R mod S. And that's a fact that is worth stating on its own very, very clearly. So what I want to do is I want to conclude this video with two important facts. The first one is the elements of R mod I modded by S mod I look like R plus I plus S mod I, and two of these guys are equal as cosets if and only if the coset R1 plus S is equal to R2 plus S. This particular equation is in the ring R mod I modded by S mod I, and this particular equation is in the ring R mod S. And all of this is based on S is an ideal of R that contains the ideal I.